This is screencast number 1 for Unit 6, Lesson 3, the life cycle of stars. By the end of this lesson, you should be able to describe the stages of the life cycle of stars. Okay, so let's get started. All right, I'm now on page 294. What is the life cycle of a star? The sky is full of stars that are at different stages in their life cycles. A star begins life within a cloud of gas and dust. Gravity pulls parts of this cloud into dense regions, and stars begin in the cores of these regions when the process of nuclear fusion begins. Okay, and you guys remember that a cloud of gas and dust out in space is a nebula. So stars form in nebulas. What kind of nebulas specifically? Star-forming nebulas. Okay, so stars form in nebulas. A nebula is a large cloud of gas and dust. Like stars, nebulas are composed mostly of hydrogen and helium. All right. They also contain small amounts of heavier elements. A nebula may be compressed by an outside force, such as the explosion of a nearby star. This causes the nebula to contract and cool. Gravity causes parts of the nebula to collapse. Remember, according to Newton's law of universal gravitation, which is something you guys learned in 6th grade, I hope, all objects in the universe attract all other objects in the universe. And the force of gravity increases with increasing mass, and the force of gravity also increases as the distance between objects decreases. So as particles within the nebula are pulled closer together, gravitational attraction increases and things actually start to move towards each other even more, and then the attraction increases, and so they move towards each other more and faster, etc. As a result, dense regions of gas and dust form within the nebula. The densest regions, which are called dense cores, form new stars. Okay, page 295. Stars emit energy by the process of nuclear fusion. The temperature within dense cores increase. At about 10 million degrees Celsius, the process of nuclear fusion begins. This process releases enormous amounts of energy. Nuclear fusion takes place when high temperatures and pressure cause two or more low-mass atomic nuclei to form a heavier nucleus. Okay? A nucleus, remember, is an atom's central region made up of neutrons and protons. The start of hydrogen fusion marks the official birth of a star. The active fusion stage is the longest stage in the life cycle of a star. This stage can last for billions of years. The active fusion stage ends when a star runs out of hydrogen. Okay, can't fuse hydrogen if it doesn't have any hydrogen left. All right, go down towards the bottom of page 295. All right, so first of all, let's visualize it. For most of its life, a star fuses hydrogen nuclei in a multi-step process that releases energy. So at the beginning, you have two hydrogen nuclei fusing because of tremendous heat and pressure into a new hydrogen nuclei, which contains one proton and one neutron. Then that hydrogen nuclei, the one that contains one proton and one neutron, slams into a hydrogen nuclei that contains just one proton, and you get a helium nuclei, which contains two protons and one neutron. Two of those slam together and produce a lot of energy, also producing a helium nuclei with two protons and two neutrons, plus two hydrogen nuclei that just are single protons. Okay, and that's going to continue as long as we have enough hydrogen to drive that process. All right, eventually though, we're going to run out of hydrogen. So look down at the bottom at the red heading where it says nuclear fusion in stars stops. A star enters the next stage of its life cycle when nearly all of the hydrogen in its core has fused into helium. The core of the star contracts under its own gravity. This contraction increases the temperature of the core, and energy is transferred to a thin shell of hydrogen that surrounds the core. Hydrogen fusion continues in this thin little outer shell. The ongoing fusion radiates large amounts of energy outward. The outer shell of the star expands, which makes the star grow much larger. When fusion ends completely, stars begin to eject matter. Stars rapidly lose mass until only the core remains. The final stages in a star's life cycle depend on the mass of the star. That is very important. Mass is the single most important factor that determines what's going to happen to a star at the end of its life. Okay? And for most of a star's life, we have two forces that are balanced. We have the crushing force of gravity, which is going to cause the star to become more and more compact, smaller and smaller. But that's balanced by the expanding force of the energy being released due to nuclear fusion. So let me stop here and I will show you what I've got note-wise. All right, on page 294, I reminded you that stars form in nebulas. Specifically, stars form in star-forming nebulas, because remember, not all nebulas are star-forming nebulas. Some of them are planetary nebulas, some of them are supernova remnants. Okay, I've got some highlighting here, so make sure that you find those sentences and underline them. On page 295, at about 10 million degrees Celsius, the process of nuclear fusion begins, so I'd make sure that I highlighted these sentences. The start of hydrogen fusion marks the birth of a star, and this stage can last for millions of years, or billions of years, excuse me. All right, at the bottom, there's some things I need you to write down. First of all, a star enters the next stage of its life when nearly all of the hydrogen in its core is fused into helium. And the final stages in a star's life depends on the mass of the star. That's really important. Mass is the single most important factor that determines what happens to a star. And remember that for most of a star's life, there are two forces that are balanced: the crushing inward force of gravity and the expansive outward force of the energy being released due to nuclear fusion.